All right, welcome back to this lesson 6's screencast. This is part 1. I am back with John. Say hi, John.
Hi.
There we go. There's a good shot of John. Perfect. And for part 1, we had question 4, which was, what is Mueller's ratchet and how does it relate to genetic load? I'm going to explain what Mueller's ratchet is. Basically, what it is when you have a population of asexual reproducing life forms. Each one of those asexual life forms can be considered its own subpopulation because the genetics never mix. So what happens is instead of one big population with a chromosomal pool that then you pull from during reproduction, with asexual life forms, you have a lot of little subsections. And those subsections will be selected against depending on how many deleterious mutations they have. And we've talked about that in the past. So usually the population with 0 deleterious mutations will end up having the highest fitness level, and then so down the list. The issue is because those populations are divided, there's a chance that they're small. And if they're small, there are certain circumstances, whether they be environmental, whether they be selection-based, that can basically prevent them from reproducing for a whole generation. And when that happens, you could possibly lose an entire subsection of your population. So with Mueller's ratchet, the theory is a population will always move towards having more deleterious mutations, because if that population that has 0 deleterious mutations doesn't have an opportunity to divide, they're gone. And then you're left with the highest fitness level being the population with 1 deleterious mutation, and so on. And the problem with that is the only way to get back to a population with 0 deleterious mutations would be to back mutate, which is a lot more rare than to forward mutate. So what ends up happening is these groups with the highest fitness level, if they're too small, they end up having this issue where they basically don't get the chance to reproduce and they're lost. And that population just keeps going down the line of highest fitness levels.
So as this ratchet turns click by click as different groups are eliminated, these accumulations of these mutations are what is referred to as the genetic load on the given population. And so with each click, as the highest fitness level is deleted or dies out, the genetic load becomes stronger and stronger until eventually the entire population will become extinct or will die out.
Perfect. Thanks for joining us for question 4. We'll get back to you with part 2.